So we are now at example 1. So what we are trying to do is compare e to the x and x squared as x goes to infinity. And it actually tells us, show that the function e to the x grows faster than x squared as x goes to infinity. Okay. There are two ways to set up this problem because we need to do the ratio of e to the x and x squared, but it does not matter which you put on top. And so I'm going to show you both ways just so that you can see how it works. Okay, so the first way, I'm going to set up my limit, and make sure that you're writing those limit statements as you go through, really important. I'm going to do e to the x on top. And so if I do kind of my original plug-in step, right, I get infinity over infinity, which makes me L'Hopital eligible. And so, again, when I set up that limit, still need the limit statement, the derivative of e to the x, derivative of the bottom, 2x. If I plug in, I get infinity over infinity again, so L'Hopital eligible for the second time. Limit as x goes to infinity, e to the x, still its own derivative on the bottom, 2. And this is the first time that if I plug in, I'm going to get infinity over 2, which is just infinity. This answer tells me that e to the x, which is the top function, grows faster than x squared. Okay. All right. Alternatively, so I'm just going to do it as an or. Okay. The limit as x goes to infinity. What if I had started by putting x squared on the top? Okay, this is definitely a legal move. All right, I'm still looking at their ratio, and it turns out this also makes me L'Hopital eligible. I don't think that's a surprise. Continuing to write that limit statement. When I take the derivatives, then I'm looking at this, which should kind of look familiar. I think you can see kind of where this is going. L'Hopital eligible for a second time on this side. 2 over e to the x, and if you plug in infinity, and I use that with air quotes, right, I get 2 over infinity, which we know is 0. Well, this answer indicates that the top function, e to the x, grows slower than e to the x, okay? So here my conclusion would be that x squared grows slower than e to the x, whereas over here, okay, my conclusion would be e to the x grows faster than x squared, but realize those two statements are equivalent.